Good morning, students. I had started with chapter 22 trigonometrical ratios in my previous class, and I had explained what trigonometrical ratios are and the sine, cos, tan, and all the 6 trigonometrical ratios such as sine, cos, tan, cosec, sec and cot for the right angled triangle. So in continuation with exercise 22a, let me take up some more questions. Question number 6. From the figure is given. It's a right angle triangle ABC, right angled at B. Both the sides AB is equal to BC is equal to A. We have to find the value of sine A. Second, sec A. And third, cos square A plus sine square A. Okay. Now, we are to find AC first. AC according to Pythagoras theorem will be square root of A square plus A square, which is equal to 2A square under the square root, that is A root 2. Therefore, I write this as A root 2. So, we have got all the 3 sides now. We can find the identities which is asked, or the ratios which is asked. Sine A will be equal to perpendicular by hypotenuse, right? Perpendicular is A by A root 2. A cancels, it is equal to 1 by root 2, and if you are to rationalize the denominator, you are to, I'll show that here. Alright, so for the time being, take it as 1 by root 2. There is no space there. Then sec A. Sec A formula is hypotenuse by base. Hypotenuse by base. Hypotenuse is A root 2. Base is A. Therefore, sec A is equal to, A cancels, it is equal to root 2. Now come to the third one. Cos square A plus sine square A. Now, cos A is base by hypotenuse, that is A by A root 2 and square of it, plus sine A is A by A root 2 again and square of it. This cancels. 1 by root 2 whole square. Root 2 into root 2 is 2. So 1 by 2, and similarly this one 1 by 2. 1 by 2 plus 1 by 2 is 2 by 2, which is equal to 1. Now I had told you the first part to if you want to simplify. So sine A is 1 by root 2. To write it in the simplest form, if you remember, we had learned rationalization of the denominator. So multiply this by root 2 in the numerator and root 2 in the denominator. 1 into root 2 is root 2 and root 2 into root 2 is 2. So the denominator is free from irrational number. You can leave the answer here also. That is also correct. No harm here. You can do up to this. Now most of the questions are of the same type. 7, 8, 9, 10, 11, 12, 13, up to 13. It's all of the same type. So I'll work out one from here, and that is question number 10. Given 4 cot A equals 3. find sine A second sec A, and third is cosec square A minus cot square A. Cot square A. Now let us apply the identity which we are given. First, cot A will be equal to 3 by 4. From here it comes. Cot A will be equal to 3 by 4. Now, draw the right angle triangle. It will be easier for you to assess the other trigonometrical ratios. Cot A, so let me take this angle as A. Cot A is 3 by 4. Cot is equal to base by perpendicular. Therefore, base is 3 and perpendicular is 4. Actually, it is in this ratio 3x and 4x. But because it is a ratio, if the rest of the terms cancel each other, x and x will cancel each other and it can be taken as 3 by 4. Therefore, take it as 3 by 4 in this case. Now, again applying the Pythagoras theorem, if I take this as B and this is as C, then AC will be equal to square root of 3 square plus 4 square, and this is 9 plus 16, this is root 25, which is equal to 5. Therefore, this is 5. We have got all the three sides of the right angle triangle. So now let us find out the first one. Sine A is perpendicular by hypotenuse, right? Perpendicular is 4 by 5. Second is sec A, and sec is equal to hypotenuse by base, which is equal to 5 by 3. In the mixed fraction form, it is 1 and 2 by 3. The next is cosec square A minus cot square A. Cosec A, if sine A is 4 by 5, cosec A will be 5 by 4 whole square, reciprocal of sine. We have not found out tan, so that cot I will find out directly, but that is given to us. Cot is given 3 by 4. So I'll use this directly, 3 by 4 whole square, which is equal to 25 by 16 minus 9 by 16, which is 16 by 16 or 1, right? So this is the third part in this. And this is how you have to work out up to question number 13. 7, 8, 9, 10, 11, 12, 13, all of the same type. Alright? One more question of the same type, but it is in terms of P and Q, and that is question number 13. Given sine theta is equal to P by Q. Find cos theta plus sine theta in terms of P and Q. Find cos theta plus sine theta. If sine theta is P by Q, take this angle as theta, a right angle in this right angle triangle, and P by Q means perpendicular and hypotenuse is Q. Now applying if I take it as A, B, C, I am to find AC. AC, applying the Pythagoras theorem, will be square root of Q square minus P square. And I cannot simplify this further. So I leave AC as Q square minus P square. I'll leave it as Q square minus P square. Alright? And now what is cos theta? cos theta plus sin theta. Cos theta is equal to q square minus p square under the square root base by hypotenuse, that is q, plus sin theta is again, it is given to be p by q, right? Therefore, hence it is equal to q is the LCM and q square minus p square plus p. So you can leave up to this. You can leave the answer to this. This is the simplified form. So you will work out up to question number 13. Thank you, children.